Hello friends, in this video lecture we are going to learn the boundary value problem. Boundary value problem. First, you know what is boundary value problem. A differential equation y double dash of x plus f of x into y dash of x plus g of x into y of x is equal to r of x with the boundary condition y of x0 is equal to a and y of xn is equal to b is called boundary value problem. There are two methods. First method is finite difference method. In this unit, two methods are given. First is finite difference method and second is cubic spin-like method. First we see the method of finite difference method. The given boundary value problem is of the form y double dash plus f of y dash plus g of y is equal to r, and here set x is equal to xi and y is equal to yi and y2 dash is equal to yi of 2 dash. Then put yi2 dash is equal to y of I minus 1 minus 2yi plus y of I plus 1 upon h2. I is equal to 1 to up to the term n minus 1. Then write the problem. Example 1. The boundary value problem is defined as y double dash plus y plus 1 is equal to 0, 0 less than x less than 1, where y of 0 is equal to 0 and y of 1 is equal to 0 with s is equal to 0.5. Use the finite difference method to determine the value of y of 0.5. Solution. First write the exact solution of problem is y of x is equal to cos x plus 1 minus cos 1 upon sin 1 into sin x minus y, from which we obtain y of 0.5 is equal to 0.139493927. Given boundary value problem is y double dash plus y plus 1 is equal to 0, 0 less than x less than 1, and y of 0 is equal to 0 and y of 1 is equal to 0. The differential equation is approximate as y of I minus 1 minus 2y of I plus y of I plus 1 upon h square plus y of I plus 1 is equal to 0 and I is equal to 1 to n minus 1. Then y of I minus 1 minus 2y of I plus y of I plus 1 plus h square y of I plus h square is equal to 0, multiplying h square on both sides. Therefore, we get y of I minus 1 plus h square minus 2y of I plus y of I plus 1 is equal to minus h square, that is equation 2. Here I is equal to 1 to n minus 1. With boundary condition y of 0 is equal to 0 and y of n is equal to 0, that is y0 is equal to 0 and y1 is equal to 0, and choosing h is equal to 1 by 2. Here x and y are given. When x is equal to 0, y of 0 is 0, that is y0. When x is equal to 0.5, then y of 0.5, that is y1. And here 1, x is equal to 1, then y of 1 is equal to y2. Given y of b is equal to 0, and y of 0 is equal to 0. These are given. Then from equation 2, implies that y of I minus 1 plus 1 by 4, h square means h is equal to 1 by 2 and square is 1 by 4, minus 2 y of I plus y of I plus 1 is equal to minus 1 by 4, that is y of I minus 1 minus 7 by 4 minus 7 by 4 yi plus yi plus 1 is equal to minus 1 by 4. Then multiplying this equation by 4 and multiplying this equation by 4, then we get 4 y of I minus 1 minus 7 yi plus 4 into y of I plus 1 is equal to minus 1. That is equation 3. Then put I is equal to 1 in equation 3. We get 4y0 1 minus 1 0 minus 7y1 plus 4y2 is equal to minus 1 minus 7y1 is equal to minus 1, because we know y of 0 and y of 2 is equal to 0, and therefore y1 is equal to 1 by 7 and y1 is equal to y1 is equal to y of 0.5, that is equal to y1, that is equal to 1.7, and that is equal to 0.14285711429. By calculate this division, then we get this value. And comparison with the exact solution given above show that the error in the computed solution is 0.00336. On the other hand, if we choose h is equal to 1 by 4, then from equation 2, y of I minus 1 plus 1 by h square is equal to 1 by 16 minus 2 y of I plus y of I plus 1 is equal to minus 1 by 16. Then y of I minus 1 minus, solving this bracket, we get 31 divided by 16 yi plus yi of I plus 1 is equal to minus 1 by 16. And with boundary value problem, with boundary condition, y0 is equal to 0 and y4 is equal to also 0. This can be solved by here x and y. When x is equal to 0, then y of 0 is equal to y0, that is equal to 0. And here x is equal to 0.25, then y of 0.25, that is equal to y1, and x is equal to 0.5, that is y of 0.5, that is equal to y2. X is equal to 0.75, y of 0.75, that is y3, and x is equal to 1, then y of 1, that is equal to y4, and y4 is equal to 0. For I is equal to 1 in equation 4, that is equation number 4, then we get y0 minus 31 upon 16 y1 plus y2 is equal to minus 1 by 16. and for I is equal to 2, then equation 4 implies y1 minus 31 by 16 y2 plus y3 is equal to minus 1 by 16, and for I is equal to 3, in equation 4 we get y2 minus 31 by 16 y3 plus y4 is equal to minus 1 by 16. Since y0 is equal to 0 and y4 is equal to 0, then above equation becomes minus 31 upon 16 y1 plus y2 is equal to minus 1 by 16, that is equation first, and y1 minus 31 by 16 y2 plus y3 is equal to minus 1 by 16, that is equation second, and y2 minus 31 by 16 y3 is equal to minus 1 by 16, that is equation third. From equation 1 it is implies that y1 is equal to 1 plus y2 into 16 by 31, and from equation 3 it is implies that y3 is equal to 1 plus y2 into 16 by 31. Put this value of y1 and y3 in equation 2. We have 1 plus y2 16 upon 31 minus 31 upon 16 y2 plus 1 plus y2 16 upon 31 is equal to minus 1. On solving this, we get y2 is equal to y of 0.2 is equal to 63 upon 449 is equal to 0.140311804, and the error on which is 0.0082. This is error of the problem. Means we use here formula and find the solution by using the finite difference method. Thank you.